Let's enlarge this thing here. And we'll center it up a little bit. I think that's as large as I can make it. Oh no, that's as large as I can make it. Okay, and we'll get my keyboard out of the way here. Move my camera. Okay, so we're going to be looking at this thing right here. Let me just put this on a book so it's looking even. I'm going to move my mouse here for a second. There we go. Okay, so I got some tape on the back. So this is basically, okay, up here where I am here, this is a metal ball. This is an insulating plastic here. This is metal, and it goes through, and I've got a glass lid on here. And then we've got these two leaves in here that are hanging down from just barely contacting this. And what this is an electroscope. And what it does is it detects charge. Okay? And we're going to look at charging by contact and charging by contact and charging by induction, sorry. And I'm just going to clean this glass plate off here a little bit before we do this. So, and I also have, if you want to see here, I'll also grab these. A bunch of, in this here, we've got some plastic lucite rods that are just cylindrical. We've got some ones that are rough on the edge, like this glass one. So you can see it's kind of rough there. So we got a plastic, we got a glass. We also have this one here, which is actually hollow. So it's not, and it's got a point on the end. So charge will, it's kind of hollow. We also got some ebonite, which is a black plasticky kind of color with a tip on the end of the rod. So charge usually focuses at points. That's why there's tips on them. Okay, and then we also got another ebonite rod that's round. Okay, and it's got a flat kind of a spot to it. And on this side, it's just rounded. Okay, so those are our charging rods. And I think we got everything else is fairly similar. Okay, got some thread in there too. Okay, and then we got different cloths and all that kind of stuff as well. So the general idea here, and I've also got a balloon, okay? So what we're going to do is we're going to use, so you can see the top area here. I'm going to charge this balloon, and then I'm going to see how it affects us. Now I'm going to put the glass back here so that so if I do this, it's not air that's moving it, right? So that's why that glass is there. However, I want to wipe that off first, which I forgot to do before we started here. Plus, I put it down somewhere. There it is. So let me just quickly do that over here with my stuff here. So I'm going to do that. Take me a minute here. And okay, so let me just put some rubbing alcohol on it. I'm just trying to clean it up a little bit here. Without putting too much fingerprints on it. And what we're going to do is we're going to do a couple of these things. Now, I'm not sure what your history is with science, because we're from different schools, but you might have done this in your grade 9 or 10. when you looked at static electricity. It's grade 9 science, I think, pardon me. So we usually do this in there. So, okay, so that's fairly clean. Let's put it in there. Now I've put some tape on the back one here so it's easier to see these leaves. Okay, so what I'm going to do is I'm going to charge up this balloon here by friction, and I'm going to use some fake fur that I've done, I think, or flannel. I think flannel will probably work. So I'm going to use this flannel, this white flannel that I've got. Oh yeah, it's charging nicely. And the reason a balloon charges nicely is rubber and flannel have opposite charges or opposite attractions to electrons. So we'll just, obviously I can't rub my head because I have no hair. Okay, so now that I've charged this balloon, hopefully enough, you can see that when I bring it close to these leaves, that the leaves repel each other, okay? Right? And I haven't touched anything yet, okay? Now, I'm just gonna, I don't have my chat on here, but I'll turn my chat on. Everybody, can you see the leaves on there? Like, can you see them move there? I can see it here nice and clear, but I'm not sure how it shows up on video. So they're repelling. So what's happening here is I'm going to just charge this up again a little bit more. Okay, so what happens there is that there's extra charge on here. And what happens is this is neutral right here. This is all neutral. And there's a bunch of electrons, and electrons are the only thing that can move inside this metal here. Protons do not move, okay? Electrons do. So what happens when I bring this close? This, let's say that it's negatively charged. If this was negatively charged, which I believe it is, so I'm collecting extra electrons on here. So if this was a negative charge, as I bring it close like this, right, the electrons from here get repelled and they move down to the bottom and they collect on the leaves down here. And then the leaves will spread out, okay, because they have more electrons at the bottom than they do at the top. So even though it's still neutral, there's a charge separation between the top of the scope and the bottom of the scope, which the bottom of the scope is very light and moves. I used to have, these are tinfoil by the way, but I used to have gold leaves in here that disappeared a long time ago. But gold is a really good conductor and they would just spread way apart. But tinfoil works to see this, okay? Now, if this was positive, the opposite would happen. So if this was positive, if this balloon was positive, the electrons would be sucked up from the bottom to the top and they'd be all on the top and there would be a deficit of electrons on the bottom, okay? So that's a charge separation. That's how charge separation occurs. Now, if I were to charge this by contact, okay? So if I take this and I get a lot of electrons on here, and then I take this and I touch the top of the scope. So I'm going to bring it separates, but I'm going to touch it. Okay? I'm going to touch it and I'm going to roll it a little bit so it has good contact there. Okay? And then I'm going to take it away. Okay? Touch. Okay. Okay? And you can see that it's still charged a little bit. I don't see if you can see. I'm going to put it at an angle here. Okay, I'm trying to put lots of electrons on here. Okay, so it's still got some separation. Watch what happens when I ground it with my finger. Okay, so I've transferred a bunch of, okay, so I've transferred a bunch of electrons here. Okay, and then I take it away, and you can see that it's repelling on the bottom, right, a little bit. So this has now become charged by contact. So if I go here, and I touch this, and I ground it, touching the ground, it's going to take all the electrons, they're going to go on my finger and into the ground, and these should drop. Watch. Okay? So now it's a neutral scope again because I've grounded it. Okay? So let me charge that up again by contact. We can use a rod. Maybe a rod would work better. Let's see. Let's try an ebonite rod here. So let's try this thing right here. Okay, so I'll charge this up. I don't know if it's going to work as good as the balloon, but we'll try it. It should focus all the charge at the point. No, doesn't work as good as the balloon because you can't. Maybe I got to use a different material. Let's try the glass rod. Maybe the glass rod will work. You got to know what the material is. I think fur is what I need. I don't have any fake fur here. And I definitely don't have any here. All right, so let's go back to the balloon. It works best. And we'll charge this up again. Okay. Okay, bring that balloon in there. Okay, I got fairly good charge on it, hope. Okay, separation of charge occurs. Okay, that's neutral. Separation of charge occurs. Touch the scope. Try to transfer lots of this electron to it. Works better if I put it at a little bit of an angle. Okay, get some more of these electrons transferred over. Oh, I touched it with my finger. Dang it. Let's put some more electrons on it. Try not to touch it this time. Okay, so I should have transferred a fair amount. Not too much, just a little bit. I'll put some more on it. Oh, I got lots on it that time. I must have hit the type I was. So you can see that they're repelling nicely there. That's a charged electroscope. Ground it with our finger. Okay, that's charging by contact. Okay, so let's summarize that quickly. Well, actually, no, we'll do charging by induction next. Okay, I'm going to see if I've got some fur here because I think it'll work better than this flannel I got. I might have some of the bottom here of this box of mine. Oh yeah, thicker. I got a nice chunk there. Okay. Oh yeah, it works really good because it's almost sticking to the balloon. So let's see, this should work better. I can hear crackling even. I wonder if we could bring the fur. No, the fur doesn't transfer. unless you're doing friction. The balloon is nice and skinny and all the charge is on the edge of the balloon. That's why I like to use it. Oh yeah, look, we got way more charge on this thing with fur. That's good, that's good. So, oh yeah. You can get way more charge on it with this fur, I'm sure of that. So you can see that it comes out nicely. And I'll just transfer a bunch here. Go ahead.
Just a question with printers. So for track and field, we have that one extra color laser printer that sits in the corner.
Yeah.
Do you guys need?
No, I bought a new printer for the Slack bought it last year, so we have, it's a black one.
Okay.
Yeah.
Okay, so you don't need it. And do you remember we had bought a laser printer that we were running on track and field for a while? That one called out somewhere.
Yeah, that one. I think that laser printer that we have, that white one. Oh, gray one.
Yeah, sitting there. So,
Oh yeah.
yeah, that one's still sitting there.
Yeah, because we bought a black one that got conked out at track and field one time. Yeah, and then I bought another black one for actually Swack bought it. Yeah.
Yeah, so that was $35 printer.
Yeah. Okay, so there we go. Charging by contact. Okay, now I'm going to do charging by induction. Okay, so charging by induction, you take a charged object. So let me get this balloon charged up. Now this one sometimes doesn't work as good, but hopefully you'll be able to see it here. So we bring the charged object that I just, so that you bring it close without touching, and then you touch it with your hand. Okay, and then I take away the balloon, and theoretically if I did it, there should be some charge on there because it went off on my finger, but we'll do that again. It might take a few times for me to get it to work. No, I need something that's more highly charged. Let me take a couple minutes to get this balloon all charged up. Oh yeah, okay, I got some there. Okay. Without touching it. Yeah, it's not going as good as I want it to. So theoretically what should happen, I think I might have, we should see it repel a little bit. Let's give it a couple, let's try a rod here with the fur. I don't know, it's not really. It's not really showing a lot, which is unfortunate, but it would work way better if I had my gold. That's why we used to have gold leaves, because the gold leaves would allow the electrons to really flow. All right, I'm going to try one more time. Try one more time. Probably the fact that I'm all charged up too, but who knows. Nah, not really showing it. I'm going to try my other scope here. I've got two. Maybe this one's a little better. Let's try this scope. Doesn't have tape on it, but I think you can still see it there. What did you do in physics today? We rubbed balloons with fur. Yay. Okay, here we go. No. It's not holding enough charge to see it clearly. Maybe if I do it the other way, I'll do it this way. I'll hold my finger on it, and then I'll bring the thing, and then it'll push electrons onto my finger. And then I'll take away my finger and the balloon at the same time. Oh, a little bit there. A little bit there. Or it could have been just the moving. Let's try that one more time. Hold my finger on it. And bring the balloon close. A little bit of movement, but not too much. Anyways, let's summarize that. So that's charging a scope. So we'll draw 3 pictures here. So let me move these scopes out of the way. Put this fur and stuff in the back here. Sorry, the induction one was not exactly the as clear as day. You can kind of see it here if you're nice and close in the lab that it moved a little bit, but not a whole bunch because there's not a lot of charge on that. Okay, so let's shrink my face down here again. Okay, so let's summarize some of our charging that happened. So let's look at separation of charge first, and then we'll look at charging by contact. And now the one thing you have to remember, and students get this mixed up a lot, is that electrons are the only ones that move. Okay? So the big point to remember, electrons move. And those are the negatives, of course. Protons do not. Those are the positives. Okay, so the positives do not. So let's do splitting or separating of charge on a neutral object. Okay, so let's say we had our up here we can do so if we had these are the positives. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 positives. So a neutral there's a neutral scope, okay, without the box around it, obviously. Okay, so if I bring it, so this is neutral, Okay, and then if I bring let's do a negatively charged object close. Okay, so what happens? Okay, so if I were to draw the same scope here, okay, this time they're going to repel, because what's going to happen is the negative is going to be forced to the bottom. The positives aren't going to move, so we're still going to have the same charge distribution of the positives that we had before, like this. And if we put a charged object, let's make it a charged balloon. And we'll put a bunch of negatives on it. Maybe a couple positives. Right? Okay, but that's charged. So this is going to repel the negatives to the bottom. So the negatives are going to be repelled to the bottom. Okay, and then the leaves repel each other. So we have repulsion. So even though it's still neutral, because this object is highly charged. Now, if this was positive, it'd be different. All the negatives would suck up to the top. And that's probably one of the reasons I can't get the charging by induction to work. It's because I'm probably charging it positively, and positives don't move as good as negatives do. Okay, so that would be separation of charge. Now, charging by contact, we touch it. So if we're doing charging by contact, let's go back to black so that we are consistent. Oops, sorry, going too fast. Let me move my brains out of there. Sorry about that. Okay, and we'll do charging by contact. Okay, this time I did a negatively charged object close to it, right? This time we'll do a positively charged object that we're going to... so the one thing to remember with charging by contact is that the scope becomes the same charge. As the object charging it. Or touching it. Okay, so when you contact it with a positive object, it'll become positive. When you contact it with a negative object, it'll become negative. Okay? Okay, hopefully we're good there. Okay, let's draw it. So first thing, we have our neutral object. So let's do our typical okay, there's our 8 positives. Eight negatives, so it's neutral. So we're gonna, it's neutral. Okay, and we're gonna bring our object close and touch it. So we're gonna bring it close and touch it. Now I'm gonna bring positively charged object touches scope. Okay, so let's draw our object. Let's do black again. Here's our scope. Ah, it's too fat. I have to always skinny that up. I forget. Ah, so there we are. So there's our scope. Okay, and we're going to get some repulsion here, so make these farther apart. And let's touch our object. Let's touch this. I got to make it a little bit closer here. So touch the edge of it like that. Okay, now we're going to let's do a positively charged one. Okay, now the important part to remember here, people, is that the positives will not move. They won't get pushed down to the bottom. They'll still be in the same pattern on the scope. But what will happen is that the electrons will be attracted to this rod and they'll start flowing up onto the rod. So and they're going to flow onto this rod. So we're just going to put a line there. Now that's too fat. Let's use a skinny green to represent them moving. That's not skinny. So this is the electrons flow onto the positive rod. Or object. We'll just assume that it's a charging rod or balloon or whatever. Okay, so there's gonna be less electrons than neutrons. Then we take it away, and we're gonna be left with I keep forgetting to skinny that up. Okay, so then I'm going to remove it. We're going to still have our 8 positives, like we normally would. But say 5 or 6 of those are missing, so we're only going to have, and these would eventually space themselves out evenly. So they might go like that, and this would be positively charged. So we remove the object. Okay, remove the charged object, and the scope is the same charge. Okay, so neutral object, contact it. The electrons flow onto the positive rod, take the positive rod away, it gets positive. Now, if this was a negatively charged rod, then the electrons would flow onto the other way. They would flow the other way. So a negative one would flow the other way. So if this is negative, Okay, so if it was a negative, the flow would be onto the scope instead of off of the scope. Okay, so that would be the opposite direction. Okay, the negatives are going to go towards the positive. So if there's lots of electrons here and a few here, they're just going to flow onto it. Okay. So that's charging by contact. Okay, the last one we're going to do today is charging by induction, which was harder to see, okay, because it didn't really work out so great because I don't think I had highly enough charged object. Okay, so we're going to do charging by induction. So charging by induction is where we touch it with our finger, which is essentially grounding the object and then removing a charged object. It doesn't charge as much, but it still does work. So we'll do charging by induction. It should take us about 10 minutes, and then that'll be it for today. So our last little diagram, let me move these back out of my way here. All right, so I'm going to flip ahead to the next page if that's all right. Okay, if I'm going too fast, just let me know. Okay, we'll flip the page here. And we're going to just do charging by induction. So charging with induction or by induction or whatever you want to call it. So we start out with a neutral object again. So put your neutral scope and put our 8 positives on it and our 8 negatives. So when something's neutral, everything's kind of spaced out evenly. 4, 5, 6, 7, 8. Okay, so nicely spaced out. Okay, now charging by induction, we're going to and we're going to do negatively charged object, close. And then you got to touch it with your finger to ground it. So we're grounding it. Okay, we're grounding it with the contact of our finger. Okay, so what happens when we touch this? What happens is the positives are still here. And I'll write out what's happening here. So our positives are still here. But because these are repelling, so some of the electrons are going to get pushed onto our finger. So these electrons are getting pushed onto our finger. So the electrons get repelled onto our finger and into the ground, right? So they're grounded. That's what grounding means. Okay, so you're removing some electrons without touching this. Okay, and then when you remove both of those, when you remove your finger and you remove your charged object, you're still going to have your positive objects. But you're only going to have like maybe 3 electrons left instead of 8. And it's positively charged. Remove the object plus the ground. Okay, and the object becomes charged the opposite of the rod. Right, that's held close to it. So it's going to push those off. Now, if this was positive, it would suck electrons off your finger onto this. So if this was positive, it would suck extra electrons out of the ground into the scope. And then you'd have a bunch of extra electrons here. So if that's positive, it's sucking electrons towards the scope or onto it. If it's negative, like this case that we drew, it's going to push them off. Okay, so that's the difference. Charging by induction, opposite charge. Charging by contact, the same charge. Okay, so that's kind of how charging by induction, charging by contact, and splitting of charge works. You could also have charging by friction, which I did do with the balloons. And that happens because of contact and physical motion causing the electrons to move around. But we don't worry about that. We worry about induction, we worry about contact, and we worry about separation of charge. Those 3 areas. Okay, so that's our lesson for today. We'll stop there. We got a little bit of time, but not enough to kind of get into our next diagram. So we'll stop there today. Okay, and if you're still working on your Handon, don't forget to get that to me by the end of the week. And I'll correct those, and then we'll get set up for our conservation quiz and things like that as that comes up. All right, so that'll be it for today. I will stop my vid and post everything up for you. And see everybody tomorrow.